Hey, what if your razor was designed by the same aerospace machinist responsible for making parts for the International Space Station, the Mars rover, and low Earth satellite programs? Yeah, we're still talking razors here, people. Henson Shaving is doing just that. Now, they're different from your typical mass market razor company. Henson Shaving is bringing the same precision to your razor that they've been bringing to space for the last 20 years. I wonder, does that make them space razors? All right, if you're like me, over the years, you've been cut or nicked or bloodied or all of those things by dull blades or bad products. And you're probably not entirely sure why. Well, it turns out that tiny little vibrations of the blade are the culprit itself. With manufacturing tolerances of less than half of a thousandth of an inch, the team at Henson support the blade with incredible precision, which ultimately limits the irritation that you get while you're shaving. And even better, the Henson razor is plastic free. It's made to last for decades, and the blades themselves are recyclable. A sustainable approach that I can fully get behind, and you know if I can get behind it, Stark Talk can too. So what are you waiting for? Head to hensonshaving.com and use code StarTalk at checkout to pick up your razor and get 100 blades for free. That's hensonshaving.com, Henson shaving.com with code StarTalk, 100 blades for free. What are you waiting for? Thank me later. Happy shaving. Yes.
Have you heard of the 5 points of Lagrange?
I gotta tell you, sounds like a Michelin star restaurant. Welcome to the 5 points of Lagrange.
Lagrange, we will serve you the best of all.
Yes, the gastro fantasy of your life.
Well, Lagrange himself was a mathematician, and he did happen to be French. Yes, as you surmised. So it turns out, after we understood what gravity is and how it worked, primarily through the equations of Isaac Newton.
Yes.
Right, so here we are. If you have two objects just sitting there, they fall towards each other. But you can actually put one object in orbit around the other. Okay? And then it's still they're still falling towards each other, but it's also moving sideways as it does it. So it never actually hits it. Okay, that's a little hard for some people to capture and embrace.
Because you got to think about it in 3D. You can't think about it
3D,
as,
exactly.
You can't think about it as just something falling.
As a line.
As a line going towards one another, right.
Correct. The moon is falling towards the Earth, but it happens to be going sideways really fast.
Right.
All right? And you combine those two facts, it takes it into orbit. So there you have it. All right. So let's think up a few things. Let's say you want to travel from Earth to the moon like in a straight line.
Okay.
Does it make sense that there will be a point where Earth's force of gravity on you will exactly equal the moon's force of gravity on you?
Oh yeah. I mean, they both have gravity. It's kind of it's an outsized tug of war.
I like the analogy, right? So we can stand on Earth and we're not just pulled into the moon. You can stand on the moon, you're not pulled into Earth. There's got to be some point where it's exactly equal.
Okay? Yeah, that makes sense.
That point is the first point of Lagrange.
Ah, exactly. That is what we like to call the amuse-bouche.
The first course of the...
Oh, Jesus. So silly.
Okay, for those who've only ever eaten at Wendy's, tell everyone what the amuse-bouche is.
So, sometimes before, if you're at an upscale restaurant, before everything starts, they will come over and they will give you just a small taste, normally on a tiny little something. And, it looks like it's a complimentary offering, but it's not. It's just...
it's not a line item on your bill, but exactly. You paid for it.
But you paid for it, so it's,
Okay, so now let's keep going. So that's a balance point number one. So it turns out that point is much closer to the moon as you might imagine. Okay? It would have to be because Earth's gravity is stronger than the moon.
Much stronger.
You got it closer to the moon for that to balance out. All right.
Right.
But the Earth-Moon system rotates. Okay? So let's think about this. If it's rotating, there's also sort of a centrifugal force in the system that wants things to fly away.
Right.
If you happen to be there. Okay. So in this rotating system, on the other side of the moon, there is a point where the Earth-Moon rotating system is flinging that in such a way that its urge to fall towards the Earth and the moon is balanced by the centrifugal force to have it fly away.
Oh, gotcha.
So there's another Lagrangian point, L2.
Right.
On the other side of the moon. Okay? And in order for that to work, you have to give it an orbit around the Earth that stays behind the moon as it goes around. Okay?
Right. So, okay, I got you. It's like the inner circle, that's the point on the Earth and the moon.
Right.
But then there's an outer circle.
An outer one.
Right.
And there's a spot where you can find that spot, calculate where that spot is. And if you have it revolve around the system in the same way the moon is, you will feel the centrifugal force push you away and the gravitational force pull you in, and you're balanced.
So let me ask you this then.
Yeah.
Okay, I'm just trying to figure this out. So on that outer point, is it taking into account the gravity of the Earth too?
Yes.
Or is it? It is.
Both the Earth and the moon are trying to pull it in the same line.
Same direction.
Yeah.
Gotcha.
Yeah. So not only is that point L2 on the other side of the moon, you might guess there's a counterpart to that point on the other side of the Earth.
Oh, right.
Why
yes, not? Of course.
Of course. Okay. So now we've got L1 between Earth and the moon, L2 beyond the moon, L3 beyond the Earth.
Gotcha.
Okay? These are Lagrange points where all the forces balance. Okay.
C'est magnifique.
The flavor balance.
Yes, the alignment of the points in front and back of the moon, the Earth, and in between, it makes for, how shall we say?
How you say it?
How you say?
C'est magnifique.
C'est magnifique.
So now there are two more points. We covered 3 out of 5. There are 2 more points. One is ahead of the moon in its orbit.
Okay.
And one trails the moon in its orbit. Okay? Ahead of and behind. And if you map this out, it forms equilateral triangles between Earth, Moon, and those points, pointing forward, and Earth, Moon, and that other point in the trailing spot. It turns out those 2 Lagrange points are special because they are stable.
Oh.
They're stable. Think this through. Look at L1. If the point between Earth and the moon is where they balance, suppose I just give you a little nudge in one direction or the other. What happens?
Well, then you're moving out of there.
You're moving out of there.
You're moving out of there.
You are balanced at the top of a gravitational hill.
Right.
Same is true for L2 and L3.
Right.
Whereas L4 and L5, if you put something there and nudge it, it stays.
Okay.
It stays. That's like the difference between balancing a marble at the top of a hill and balancing a marble at the bottom between 2 hills, right? The top of the hill, a gust of air will send it over the side. A gust of air, when it's at the bottom between 2 hills, it'll move, but it'll go right back
Comes
to where
right
it was.
back.
Okay? The L5 Society, you may have heard of it from decades ago, is a group of people who wanted to colonize space, and they were going to build a space habitat at L5.
Very, very Illuminati of them.
Yes, it was. Let's escape, leave Earth behind, while they blow that was during the Cold War too. So that's the difference among these places. So the L5 Society, they've got a place they can haul all manner of hardware, and it'll just stay there. And they just grab it and assemble it, and you get your habitat module.
It's like a natural space station.
Yes. Well, in terms of location, yes.
In terms of location, yeah.
Yes. Okay. So now, any pair of objects have these Lagrangian points. any pair, okay? The Earth and the Sun have Lagrangian points, okay? So there's a Lagrangian point between Earth and the Sun, and one beyond the Earth and one beyond the Sun, just like there was with the Earth and the Moon.
The Earth and the Moon. Right.
Okay? The one beyond the Earth is 1,000,000 miles from Earth, and that's where we put the James Webb Space Telescope. Because at that location, Earth permanently eclipses the Sun.
Awesome.
Preventing the sunlight from streaming onto these very sensitive detectors that's trying to find very dim, very cool objects in the outer universe.
That is brilliant. It's kind of like the equivalent of when you don't have your sun visor down in your car and you just take your hand and you basically block out the sun so that you can see beyond what's the front of your car. It's like, or World War II pilots, and I learned this from watching a TV show, so I don't know if it's real or not. Okay, I hate quoting TV shows because you never know if they're lying to you.
You're good half the time, maybe. Okay, yeah.
But they said when the guys were in the fighter planes, they're not the prop planes like Spitfires, and they just have the all glass, cockpit. That when the sun would come there, of course they don't have a visor, it's all glass. That one of the things you would do is just take your thumb and place it in a point where your thumb is blotting out the sun so that you can see the surroundings around you.
That's exactly what's going on with the James Webb Space Telescope 1,000,000 miles from Earth, in the opposite direction of the sun, at the Earth-Sun L2 point.
That's awesome. That is great.
It's totally good. That's why it's called rocket science. Okay. As a matter of fact, it is rocket science. So, you want some more Lagrangian points?
Yep.
Okay. There's a satellite at the Earth-Sun L1 Lagrangian point that is always between Earth and the Sun, and it's always just looking at Earth. It's just staring at Earth. Okay, that's the Discover satellite that has continuous monitoring of one side of the Earth as Earth rotates.
And it's actually pointed and focused on just one house of the guy who created it and is waiting to see what his wife is doing. I went through all this. I know you're doing something, girl.
I got this $1 billion satellite for the proof. All right, so the thing to know here is for the Lagrangian points that are not stable, that's L1, L2, and L3, it doesn't take much energy to keep it there, the station keeping, okay? So the James Webb Space Telescope at the Earth-Sun L2 has fuel that as it begins to slowly drift away, they send it back, okay? So I didn't want to misrepresent the stability of that point. You think of a marble on a very narrow sloped hill. It's a very wide hill.
Right.
Okay? It's a very wide hill. So it'll start rolling off the hill. You just sort of push it back a little with hardly any energy because it's not a steep hill. So you just push it a little bit, you get it back in place. So you can still use these unstable Lagrangian points, but you need station keeping energy to do so.
Wow. It's kind of like when you have a little child that you're walking with. Every once in a while, that kid want to run ahead. You're like, hey, get back here.
Okay.
Because you don't want it to run into the street,
No, it's true. It's true.
Yeah.
One last thing.
Go ahead.
Okay, you ready? The stable Lagrangian points in the Sun-Jupiter system. Okay, everybody, any two things orbiting each other has 5 Lagrangian points. So the Sun-Jupiter, you go ahead of Jupiter and behind Jupiter, there are pockets in the space of the solar system that have trapped asteroids. They're leading asteroids and trailing asteroids.
Asteroids check in, but they don't check out.
Check out. It's exactly right. Because it's a stable place. It's at the bottom of a gravitational well. And the trailing asteroids are called the Trojan asteroids.
Right.
And the leading asteroids are called the Greek asteroids. And so a little bit of, of history there.
They should have called them the Spartans. This is Lagrange.
And there are 300 of them. So Lagrangian points matter in the solar system when we're looking at where things collect, where things drift, what they drift out of, and we are exploiting those for our own gain, where we're going to put telescopes and possibly the future of habitats.
Yeah.
Orbiting habitats that we put people where all the Illuminati go, as you suspected. All right, Chuck, that's all the time we got. That was Lagrange.
That's right. That was suckly blue. Thank to God, it was absolutely delicious.
I'm trying to think what wine we would have had with that. A little bit of Bordeaux. No, I don't know. No, Chateauneuf du Pape.
Chateauneuf du Pape. The finest Bordeaux in all of Bordeaux.
All right, let's get off of this before we get hate mail from the French out there.
Absolutely.
All right, this has been another explainer for Star Talk, all about Lagrange. Until next time, keep looking up.